token to the API following the auth2 spec, which specifies that you should pass that token in an authorization header with a prefix of bearer. In Angular, there are several ways we could go about doing this. Let's start with the simplest way to understand, specifically manually adding the header to the outgoing HTTP request when you make it through the HTTP client. Before I do that though, I need to add a method to my auth service to allow me to get the access token if the user is logged in. I could use the user object that is in the service user property, but that one is not populated until the user explicitly logs in or an isLoggedIn check occurs. I'll add a more direct way to get the access token if there is one to make things a little simpler. I'll add a method named getAccessToken. In that method, I will call getUser on the user manager, which again returns a promise that produces a user object. I'll add a promise handler, and in there I will check if the user is not null and the expired property on the user is false. If so, I can return the access token property of the user. Otherwise, I will just return null. And then I need to return the promise result of the getUser call to pass the resulting promise that produces an access token to the caller. Now I want to pass that access token when my client code is making calls to the project's API. To do that manually, I can go into the project service here and go to the getProjects method where it's calling the API for my project's listing. To manually set the header, I'll need to create an HTTP headers object that comes out of the same module as the HTTP client. So I'll add that to my import statement up here. Next, I'll need to have the value for my access token available in the getProjects method where the request is being sent. So I'll add the auth service to the constructor so an instance gets injected for us. Then, in the getProjects method, I'll call the getAccessToken method I added a moment ago. Once that promise produces the access token, I can construct an HTTP headers object and call the set method to set the authorization header to a value of bearer, space, and the token value. Now I need to move the HTTP call inside this promise handler and add the headers to the call. But I still want to return an observable of project array so that the consuming code does not have to change. To do that, I can use the toPromise method to convert the observable from the HTTP call into a promise. Then I can return that from the promise handler of the getAccessToken call, and then use the from operator of RxJS to convert that back into an observable that I can return. With that code in place, I can save, go back to the app, go to the My Projects page, and behold, we are now getting our projects again. So at this point, we could go to each of the individual service methods where an HTTP call to our APIs is being made and add the access token to the headers manually, like I just showed. The problem with that is it would obviously add a bunch of duplicate code that's hard to maintain. One of the reasons the Angular team deprecated the original HTTP service from Angular 2 and replaced it with the HTTP client service in Angular 4.3 and later is because the original service did not support an interception model. When making HTTP calls from a client, you often need to have some custom code that gets invoked right before a request goes out or right after a response comes back in, regardless of where those calls are being made in the application code. In our case, at this point, what we want to do is add the access token to the authorization header right before any call is made to our APIs. The HTTP client service enabled this using what is called an HTTP interceptor. So let's create an interceptor that will add our access token to the requests automatically for us. I'll add a class to the core module here named auth-interceptor.service.ts. In there, I'll again use a code snippet to stub out the boilerplate code that is needed to create an interceptor class that sets headers on the requests. So I'll type a dash to get a list of snippets from John Papa's Angular snippets extension, and then select the one that is for an HTTP interceptor with headers. I'll name the class auth5 and I'll set the provided-in property on the injectable decorator to core module. In here, we will basically be doing the same thing I showed a moment ago to manually add the header, but by doing it here, it will be done automatically for all requests. So first, I'll inject a reference to the auth service in my constructor. Then, in the intercept, as I did before, and create the headers as I did in the project service. Then I just pass those headers to the request clone method. I will return the result as a promise, since it's wrapped in a promise again, and then convert what comes out of that into an observable. Notice the structure of this interceptor. It is part of a handler pipeline architecture used by the HTTP client. So when your intercept method gets invoked by the HTTP client when a request is being made, the request is passed in as an HTTP request object that you can inspect and or modify before it actually goes out on the wire. You also get passed this HTTP handler parameter named next, which represents the next piece of middleware in the pipeline. The expectation is that you will do what you need to do, then invoke the next handler, unless what your interceptor is designed to do is block the request from going out based on some criteria. You can also use an interceptor to look at the response that comes back after invoking the next handler. I'll get into that later for detecting 401 and 403 status codes and using those to drive renewing your access token or sending the user to a login page and showing an error. While I'm here, you should consider whether it's appropriate to blindly add the access token to any request going out from your app. I probably can't anticipate how this app is going to evolve over time, and it's certainly possible or likely that there may be calls going out to other APIs besides my own. So I probably don't want to blindly add my access token to all calls that go out, only those that I know are going to my own APIs. So I'll add a check here to see if the request is going to one of my APIs by using the URL that is in my constants and only add the access token if they are. Once your interceptor is defined, you need to hook it up to the Angular HTTP client infrastructure. The way you do that is to go into the ng module where your interceptor is defined and go to the provider section of the module. In there, add a provider object that sets the provide property to the HTTP_interceptors object from Angular, set the use class property to your interceptor class, and the multi-property to true so that you could hook up other interceptors elsewhere in your app. If I save those changes and go back to the app, if I look in the debugger, I can see there's an error being thrown due to issues with dependency injection of providers. The issue here is that my other service components in the core module are using the provided-in property on the injectable decorators to get them added to the module. But now I need to explicitly configure a provider in the module class, and that results in problems because some providers are being added one way while the interceptor is being added another. So the quickest way to resolve this is to go remove the provided-in property from each of the service components' injectable decorator, then go add those modules explicitly to the module providers. Now that they all get loaded in the same way, that resolves the injection issue. With that code in place, let me go back to the app and go to the details for one of the projects in my projects listing. That calls a different method in the project service that does not have the authorization headers hooked up manually. And yet, you can see the call is succeeding. If I look in Fiddler, you can see that is because the interceptor is adding the bearer token header that we need automatically. So those calls are being allowed through at the API. If I look at the logs at the API and the STS, there is one new issue introduced. It is a CORS warning that tells you cannot leave cores wide open with a wildcard domain when also allowing credentials through. To fix that, I need to go add my client domain as a specific domain that is allowed through with credentials. And I'll do that in the STS as well. And now, if I go refresh the app, you can see those warnings are gone now. Next up, let's look at filtering data based on the caller identity. Now that the calls are being authenticated in the API, there is a security context that will be available to your code in the back end to make decisions about what the caller can access. The way this manifests itself is going to be very dependent on what technology or framework you're using for your back end. In .NET apps, whether full framework or .NET Core, what happens is that a security principal is established based on the contents of the access token. This principal is called a claims principal and will contain all of the claims that came in through the access token after it is validated. To get to it, you can use the user object on your controller base class, or you can use a static reference to claimsprincipal.current. So one scenario you can use this in is to filter data returned by the backend based on who the caller is. To see what we have available to us, let me just dump all the claims and their values out to the console window when a call comes into the getProjects method. I'll go back into the client app, load the projects view again, and then go look at the console that's running the API site. There, you can see a bunch of claims dumped out, most of which we've already talked about. Note that some of the claims have URLs for identifiers instead of the short token names we saw when looking at the tokens in the jot.io site. This is because the Microsoft Authentication middleware sets up some default mappings to URIs for the claims that have named URIs associated with them. That's not necessarily a great thing, because as you can tell by the years in some of these URLs, those mappings are quite dated and are not part of the auth2 spec. So I'm going to switch from the Microsoft Authentication middleware to a wrapper around that is provided by Identity Server using a NuGet package called Identity Server 4.access token validation. Once I've added that package, I can go replace the authentication configuration in the startup class configure services method to use Identity Server's helper methods instead of the Microsoft ones. With those changes in place, if I run again, you can see the claims being dumped out to the console are back to having the same names as the auth2 spec. So now, if I want to filter the projects based on the user, I just need a relationship in the data model between a user ID that comes in from the STS and a project. It turns out I already have that implemented as part of the data model. In the model types, there is a user permission class that links a project to a user by their ID. And it also has a value to specify what level of access that user has to the project, which I'll use a bit later. So in my getProjects method, all I need to do is get the value of the subject claim from my claims principal, which again is the user ID at the STS, and then get the list of permissions for that user ID and filter the project list based on those permissions. Once I add that code, if I fire things up again, go log out as administrator and log back in as Alice, I see just the projects she has access to. And if I log out again and log back in as Bob, you can see he has a different set of projects he has access to. Next, let's look at adding access control checks into the API methods that change data. The user permission objects I used in the last demo to filter data are an application-specific access control mechanism. They link a particular model object for this application, specifically a project, to a user ID, and are additionally specifying a level of access to that resource, whether the user has view or edit permission. You can see that here in the admin part of the app where the admin can assign those permissions to a user for a given project. Now, it turns out at the moment, any user can get in there and make those assignments, so could just grant themselves access to everything. Obviously, that's not secure. I'll address that in a little bit. But when the user is viewing their projects and goes into the details for a project, they should be restricted to not add, delete, or edit milestones unless they have edit permission. As discussed before, the only secure place to enforce that access control is on the back end. So let me go into the controller methods where those operations occur and add some code to check and make sure the user is authorized to perform those operations. Down here at the bottom of the project's controller are the methods for adding, updating, or deleting a milestone. So I just need to add an access control guard into those methods and return an appropriate error if the user is not authorized for those operations. The code to do that is going to depend on the app, the framework, and the permissions mechanism you're using. In this case, I just have that simple user permission mapping object as part of the data model. So I'll add a helper method here to go look up the permission for the user and the project based on the milestone that is being edited and return a Boolean flag to indicate whether they do or do not have permission. Now I'll add a call to that method in each of the add, delete, and update methods, returning a 403 forbidden response if not. Likewise, some of the other operations in this controller should be restricted based on the user's permissions as well. So I'll also add a helper method to check permissions for project level operations. Then I can go insert a call to that helper and return a status of forbidden if they do not have edit permission in the method for updating a project and view permission in the get project method. We'll come back to the other methods because those should be restricted to an admin. Now, let me fire up the app. I'll sign out and sign back in as Alice, and she only has view permissions on this first project. So if I go and edit the milestone and try to save, we can look at the error in the debugger and see that in fact we get a 403 response back. So now our access control for normal users is working as desired. Obviously, having the app crash if you do get a 403 error back is not a good idea. And we should make sure that a user can never intentionally get to data or actions that they don't have permissions for in the first place. But just remember that you still always need to assume someone may try to call your APIs with either a hacked version of your client code or a separate tool like Fiddler, so you always have to have the protections like we just added on the server side. Next up, I'll deal with 403 errors if they occur using our auth interceptor. One thing you might want to add to the client is detection of authorization errors being returned to the client, and send the user somewhere appropriate in the app or show an error if they do occur. A simple way to do this is to leverage our auth interceptor again to look at the responses coming back from the server, in addition to modifying the requests as they go out to add the access token, as we have already done. One question you'll have to decide on is what is appropriate to show to the user if an API authorization error does occur. If you've added client-side authorization code, like I will show later in the course, and are keeping that in sync with the authorization rules on the back end, theoretically, the user should never see an authorization error unless they are trying to hack the app by modifying the code. But keep in mind there can always be latency between what the client knows and what the back end is enforcing, even in a nearly perfect system. So what I'm going to do for now is add a simple view that we can route the user to that tells them they have an authorization problem and give them the option to log out and log back in with another account that presumably would have the right permissions. So I'll go into my home folder here and add a view component named unauthorized.component. I'll also add its HTML template file. In the markup, I'll simply show an error message saying they were unauthorized and give a link to give them the opportunity to log out and log back in with another account. I'll go into the component code and inject the auth service in the constructor, and then add a logout method and call logout on the auth service from there. Now I need to add that component to my app module declarations and add a route in my routing module to get to it. Next, I want to trigger that navigation automatically if a 401 or 403 status code is returned from an HTTP call. So I'll go into my auth interceptor and add a little code. First, I need to pull in an additional operator from RxJS called tap. So I'll add that import here. I'll add the tap method into the pipe for the observable from calling next. I don't want to do anything in the normal case, only if we get a 401 or 403 response back, which will be treated as an error. So in the error handler for the tap method, I'll check to see if it was an HTTP error response. If so, I'll check the status code, and if it's a 401 or 403, I want to route the user to the unauthorized view I created. Now, if I save those changes, go back and make sure I'm logged in as Alice, then go to the first project and the first milestone, try to edit and save, and boom, I end up on my crude unauthorized view and could click the logout to get logged out if I wanted. Another thing you might want to base authorization decisions on is a role claim or other custom claim. Each identity provider will be a little different on how you can add custom claims into the access tokens that are issued by the STS. I've modified the Identity Server 4 code that I am using for the STS by adding this custom profile service that I can use to add a role claim of admin if the admin user is logged in. We can use that for access control or data filtering, similar to how we use the identity of the user. If I go into the Get Projects method in my projects controller, this is being called both to display the list of projects for an individual user when they go to My Projects, but it is also being used for an admin when they go to Manage Projects. So what I can do here is simply modify the code to check for a role claim of admin, and if present, return all projects, since an admin has no projects explicitly mapped to them, but should be able to see and edit everything. So I'll add a check here for user.isenroleAdmin, and if that's true, I'll return all projects. If not, I'll filter based on the user's permissions. I'll also go to the method getProjectUsers, which should only be called by admins when going into the Manage Projects page, and I'll add a role check there with an authorized attribute. That basically prevents the caller from executing the method unless they are in that role. I'll do the same on Post Project and Delete Project, as well as the whole user permissions and account controller classes, which will apply to all the methods in that class unless overridden at the method level. And then I need to add a check for the role on the guard statements I added earlier that check access for add, edit, and delete project milestones, and to the get and put methods for projects. If I run that and go to the client app, sign in as admin, and go to My Projects or Manage Projects, you can see I'm now getting back an entire list. If I log out, log back in as Alice, then go to Manage Projects and try to delete a project, you can see she gets an unauthorized response back and is directed to the unauthorized page. Later, I'll make it so she could not even get to that page without hacking the code. Even though role-based access control like this has been popular in the past, it's important to realize that the claims issued by the identity provider should be linked to that user's identity, not application-specific roles or permissions. As mentioned before, introducing application-specific information into the STS will defeat a lot of the decoupling that is intended with having a separate identity provider. So instead of using a role claim issued by your STS, you should consider using an authorization system on the API resource server side to look up what permissions a user has for just that resource. In ASP.NET Core, the mechanism for doing this is called authorization policies. I won't go into that in this course, but you can check out the ASP.NET Core documentation for more information. So that wraps up this module on authorization with OAuth2. You've now seen how to pass your access tokens in the authorization header as a bearer token and have the backend enforce that you need that. You've seen how to manually add that header on the client side, or better yet, use an HTTP interceptor to add it automatically for you. You also saw how to use the interceptor to watch for authorization-related status codes and take some action based on them. You saw that because the user ID is passed as the subject claim in access tokens from the STS, you can then use that to either filter data or enforce access control rules in your API logic. And finally, you saw that if it makes sense for your app and the STS to include custom identity claims or role claims in the issued access tokens, you can easily look for those claims on the server side to make authorization decisions based on them. Next up, we will look at refining the user experience on the client side, both in terms of managing the tokens and using client-side knowledge of the security context of the user to do things like hide or disable elements or block navigation to pages that the user should not see. Hi, this is Brian Noyes. In this